So how much do you remember about trigonometry? Anything? Go on. And the long adjacent. What? Hypotenuse? What's the name of the other side?
Opposite.
Opposite. Okay. And yes, the short forms for the three trig ratios we learned were sine, cos, and tan. And then the long forms are sine, cosine, and tangent. Okay. So and what do we use it for? Triangles? Any type of triangle? Right triangles. Right? And what did we do? What did we do like with these things? What did we find? Missing sides, missing angles, right? Okay. So that's basically trig in a nutshell. You guys nailed it. Okay. But we just let's have a little refresher on how we find adjacent, opposite, and hypotenuse for sides in a triangle, and what exactly the trig ratios mean, and then let's do some examples where we use them to find missing sides and angles. So remember, when we label, any shape, any polygon, but when we label a right triangle, we use capital letters to label where the vertices are, or there's also angles there as well. And we use capital letters for those. And then we use lowercase letters for the sides, the three sides. And what we do to label them, like if we label this capital B for this angle, and if we go to its opposite side, we would call it little b. So angle C, opposite little c. Angle A, opposite little a. Or you can just call them by their capital letters. Like I could call this side C, or I could call it AB. I could call this side little a, or I could call it capital BC. And so on. Okay, so when we use trigonometry, we look at the acute angles, because in a right triangle, there's one right angle, and there's two acute angles, less than 90 degrees, always. Okay? And then this, depending on what acute angle we're talking about, that dictates how we're going to name the sides opposite, adjacent, hypotenuse. Well, hypotenuse is always the same. How do you find the hypotenuse in any right triangle? Sorry, how do you locate it? Like, where's the hypotenuse here? Opposite. Say it. Right. Yes. I mean, it's the longest side in the right triangle, but the way to find it is go to the right angle, draw an arrow out from it, and the side that you hit will be the hypotenuse. Okay? So we've got that one done. Now we just have to figure out which one are we going to call opposite, which one are we going to call adjacent. Well, if we're talking about angle A, how would I find the opposite side to angle A? Like what side, I know this is, little c is the hypotenuse, which of these sides is opposite angle A? Little a, because again, I can draw an angle out, or sorry, an arrow out from A, and the side that I hit will be called the opposite. Which means by elimination, this third side is the adjacent. That's usually the best way to find them. Locate the hypotenuse, then the opposite, third side's got to be the adjacent. So what side is opposite angle B? Little b. Or I could call it capital AC. And adjacent to angle B? Little a. Because we know C is the hypotenuse. So little a or BC. Okay, here's how we define the three trig ratios. And again, it depends what acute angle we're talking about, because the opposite and adjacent sides change depending on what acute angle we're talking about. So if we're referring to angle A, and if we want to find the sine of angle A, that is the ratio of the side opposite angle A to the hypotenuse, or we could say, in this case, in using the triangle above, it would be little a over capital or over little c. Or if you're going to use capital letters, BC over AB. Either one's fine. The cosine is the ratio of adjacent to hypotenuse. So which lowercase letters would I use there? Using the triangle above. What's the name of the adjacent side to A? Little c? Little a? Little b? What? Give me the lowercase letter.
B over C.
B over C, thank you. Or if I use capital letters, AC over AB. Good. And then finally the tan. What little letter over what little letter? Because it's the opposite side angle A to the adjacent side to angle A. A over B. Or BC over AC. Either one is correct. Okay. And whether you remember those again, SOHCAHTOA, and you can see why we use that. So as in SOH, sine equals opposite over hypotenuse. Ka is CAH, cosine is adjacent over hypotenuse. TOA is TOA, tan is opposite over adjacent. I'm not going to worry about this one here, finding the trig ratios for angle B. I think we're pretty good at this. Okay, so what if I actually give you the lengths of the sides and ask you to find the ratios? We're not asked to find the angles here. We're just asked to find the ratios of certain acute angles. So what would be the sine of A? Opposite over hypotenuse, 5 over root 41. And you can leave it like that. Remember when we did radicals earlier this year, we couldn't have a square root in the denominator. We're going to say that's okay for this one. And these sides actually form a right triangle because 4 squared plus 5 squared is 41. So that hypotenuse will be square root 41. What is the cosine of A?
4 over 41.
4 over root 41. The tan of angle B?
4 over 45.
4 over 5. And the tan of angle A? 5 over 4. So remember, order matters. And what acute angle we're talking about matters. So now that we know, or are refreshed our memory with regards to the 3 trig ratios, how do we use them? Like you guys said earlier, to find missing sides and angles and right triangles. And what we do is we use the trig ratios to set up an equation. And then it's just equation solving. And there's really 3 situations. Did I miss something? Oh, heard mumbling. Usually that means I missed something, made a mistake, and somebody desperately wants to point it out to me. Okay, this one. We are given one of the acute angles is 25 degrees. And the vertical side is X, so that's the side we're trying to find. And we are given a third side as 11. So the first thing we need to do is figure out what trig ratio are we using. Well, if this is the angle, what's the name of this side? Opposite, adjacent, hypotenuse. Opposite, this side, hypotenuse. So O and H means sine. So the sine of the angle, and we know it's 25 degrees, will equal the opposite side, which we're trying to find X, over the hypotenuse 11. We call this trig equation because it's got a trig ratio in it. It's also called the fraction equation because we have a fraction. And what's the goal of equation solving? Get X by itself. So I'm just going to rewrite this. What do I need to do to get X by itself? Multiply each side by 11 because times 11 divide 11 cancel. Put the 11 in front of the trig, not after it. Because then you won't confuse, like if you put 11 after here, you may confuse them with finding the sine of 2,511. So this is how we're going to find X, 11 times sine 25. So this is where you pull out your calculator. And you want to make sure it's in degrees. Otherwise, it will give you a strange answer. And if I ask for the sides, I say, yeah, 2 decimal places, what would we get? 4.65. If you're stuck in radians and you're not sure how to get to degrees with your calculator, let me know. So that's one type of trig equation, where we're asked to find the missing side, and when we set up the equation, the unknown's up top. The second type is we're asked to find a side again, but when we set up the equation, the unknown's going to be on the bottom. So in this one, here's the angle, acute angle I'm dealing with. I'm given 68. This side is called the opposite. This side would be the, which means the trig ratio I'd use is 10. So the tan of the angle, 68 degrees, is equal to the opposite side, 8, over the adjacent side, which is the unknown. And then we're back to equation solving. I'm just going to rewrite this. Always want to get rid of fractions right away, so I would multiply both sides of the equation by y. So times y divide y, cancel each other out. Y times that. So I get y times the tan of 68 degrees is equal to 8. Still don't have y by itself. I've got a times tan 68 with that. How do I get y by itself? Divide by tan 68. Whatever you do to one side, you do to the other. So in this case, to calculate my missing side, I'm going to divide. And round to 2 decimal places again. So I'm going to get y is approximately Sorry, 2.23, what was the first part? 3.23? Finally, what's the third situation? You're asked to find a missing angle. So in this case, we are asked to find this acute angle. We're given two of the sides. What is the name of this side in relation to the acute angle we're trying to find? Opposite, adjacent, which means tan again. So the tan of the angle is equal to the opposite side 5 over the adjacent side 13. Just going to rewrite this. Well, we've almost got x by itself. There's just a tan with it. How do I get rid of just the tan? Tan inverse. Tan inverse and tan cancel each other out. So that means you're going to have to do the tan inverse or second tan of 5 over 13. And this one we're going to round to the nearest degree. $21. Okay. Okay, so that's a review. Exercise 4.1 is just all on right triangle trig. I just want you to get used to the ratios again and solving algebraically, because we're going to go past this stuff this year. What happens when we're given a non-right triangle? What do we do? Okay, and we'll see, we can use a special type of trig for that. And what if we're given angles that are greater than 90 degrees? How do we deal with those? Because all the trig we've done are angles between 0 and 90. So that's going to be the focus of this year. That will continue on later.